So in P3, we're going to talk a lot about equations and inequalities. So the first part of the section just goes over some properties. These are things that you already know, things that you just need to know how to use them, but a lot of this you just know in your head already. So the first thing is the symmetric property. You would see all those properties listed on page 24, but those names are not super important. But the symmetric property, symmetry, left side, right side, same thing, provides some symmetry. So if we look at this, shows left side equals right side or right side equals left side, just called the symmetric property of equality. But what I'm more interested in is what property would you use to solve for x? So if you look at this, you would probably know that you would have to subtract 2 from both sides. So subtracting actually is adding a negative number by definition. So we would call subtracting 2 from both sides using the additive property of equality. So I just shortened the additive property of equality there. But again, since subtraction is like addition with negative numbers, it's still a part of the addition property of equality. Same thing here with 3. We would know that to get x alone, we would divide both sides by 2. So because we are dividing, and dividing is actually multiplying by a reciprocal by definition. So we're going to call this the multiplication property of equality. And again, I'm shortening that for you. So as we go down, we're just going to kind of be solving some of these equations. But if you look at this equivalent equations just mean that they're equations that boil down to the same solution. So any equation where x equals 3 would be an equivalent equation. So 2x equals 6, we could figure out that x equals 3. Or even if I were to move the 6 to the other side and I have 2x minus 6 equals 0, this is also an equivalent equation. All three of these say x equals 3 if you were to solve them. So page 25 has some things that you can do to solve an equation. To get equivalent equations down, it talks about combining like terms, reducing fractions, removing symbols, through like distributing. But adding, subtracting, multiplying, dividing to both sides, those are things that we know a lot. So we're going to focus on this equation and solve it. So if you look at that, the good first move here is to distribute. So we'll distribute both sets there, and we'll get 2x minus 6 plus 6x minus 12 equals 4x plus 3. Remember, the parentheses show the starting and stopping points of where to distribute. So that's how we know the 2 stops distributing here and doesn't keep going over here. Then we can combine some like terms. So the x's can come together, and then so can the regular numbers. We'll get 8x from combining the x's, and then we'll get a minus 18 from the numbers equals 4x plus 3. Now, with this equation here, there's some options that you have. There are actually 4 valid steps that you could take. But something that I like to do is always group the x's up first, and I also like to keep the x's positive if I can. So that to me shows me that I would subtract 4x from both sides and get 4x minus 18 equals 3. Then this becomes a 2-step equation, which you guys have done since middle school, so I'm confident you guys could do the rest of this equation on your own and get that x is equal to 21 over 4 or 5.25. So being able to solve equations like these, things that I should be able to assume you can do rather flawlessly now that you're in pre-calc. Over on the right, though, fraction equals fraction, something we got to talk about. So there are 2 different ways you can do this. We've got them both here, clear the fractions or cross multiply. So cross multiplying is something that a lot of people know, so I'm going to go over that method. But cross multiplying you can only use if and only if you have one fraction equals one other fraction. So cross multiplying, we could kind of put the x in. The 6 gets multiplied by the 2y minus 3, and then we set that equal to the 4 getting multiplied to the 4y plus 5. Then we'll treat it just like we did the last equation. We'll distribute. We'll do it to both sides, where I'll distribute this and this to get 12y minus 18 equals 16y plus 20. Again, I usually like to group the variables together first, and I'll actually bring the variables over to this side and the numbers over here all in the same step. So when I subtract 12y to both sides, that means I'm bringing the left over with variables, so I'm going to go from right to left with my numbers. So we've got a couple sets that go away. Negative 18 minus 20 becomes negative 38. 16y minus 12y is a 4y. When I divide both sides by 4, I have negative 38 over 4. That can get actually reduced as a fraction down to negative 19 over 2. That would be an acceptable answer. Or you could go to negative 9.5. I would accept either of those answers. Always make sure you're reducing in this class if you can. Moving on to the back side, we've got inequalities. So page 27, it says there are less properties. And so what is different with the multiplying property? Well, if you guys remember the multiplying and dividing rule with inequalities, it's that when you multiply or divide by a negative number, you've got to flip the inequality sign or switch it. So we'll say what's different is you switch the sign when multiplying or dividing by a negative number. Some people will also call it flipping the sign when you do that. Either way, it works. But we've got similar style equations here that we're just going to work through, and then when we multiply or divide by a negative number, we'll make sure to switch the sign. So first thing here, I'm going to distribute 3x minus 21 plus 3x greater than or equal to 7x minus 8. And this negative right here, it's a negative 1 that's all getting distributed out. So negative 1 times negative x will be a positive x, and then negative 1 times 3 will be a negative 3. Now here I did multiply by a negative number, but the important part about switching the sign is that when you multiply or divide by a negative number on both sides. So that's when you divide both sides by 2 or negative 2, or multiply maybe by a negative 0.5, things like that. You've got to remember that it has to be on both sides. So this one did not count. So then I'm going to just clean it up. I'm going to combine some like terms on either side to get 6x minus 21 is greater than or equal to 8x minus 11. Same thing here. I'm going to choose to keep things positive. So I'm going to subtract 6x from both sides, and then I'm going to add 11 to both sides. Some things go away. We're going to get negative 10 is greater than or equal to a positive 2x. Then I'll just divide both sides by 2 and get negative 5 is greater than or equal to x. You're allowed to have x on the right-hand side, not a problem. Over here, though, this is called a compound inequality. So compound inequalities mean you've got stuff on the left and the right side. We did this actually a little bit in P1, but we didn't do any solving. With the solving, the idea is that you solve from the middle, and then instead of doing things to just, you're still going to do it to both sides, you got to do it to actually the left, middle, and right. So as I'm solving this, the first thing I want to do is multiply everything by 4. So when I multiply everything by 4 here, I'm going to get negative 20 over 2 is less than 2x minus 6, which is less than or equal to 24. Now negative 20 over 2 is negative 10. You could have done that all in one step, but I separated it for you in case you needed to see it. But you see how we did the solving step to the left, middle, and right to continue to get x alone. Then I will add 6 to each side, keep solving this. So negative 4 less than or equal to 2x, which is less than or equal to 30. Then divide all 3 sides by 2, and I'll get negative 2 is less than x, which is less than or equal to 15. And then that becomes our answer because we know that we have to get x alone. We did all the right solving steps to now the left, middle, and right. We could graph this, but we don't have to. Last kind of thing we'll solve today is absolute values. So what do? Well, if we look at the absolute value of x is greater than or equal to 3, we got to think, what kind of numbers are going to make that work? How do we get rid of absolute value? Well, we know that the positive or the negative case helps us out. So we know that what's on the inside could be positive, could be negative. So we know that you could have the number x being greater than or equal to 3, or its opposite, negative x, being greater than or equal to 3. We don't know if it's the number that we picked or its opposite, that when we take the absolute value would still be holding true to having its absolute value. 4 and negative 4. Both of their absolute values would be greater than or equal to 3. Well, this is already solved down for x. Now we got to solve this down. So I will divide both sides by negative 1. But now I'm dividing both sides by a negative. That means I need to switch that inequality sign. And now I have both my answers. Both of these answers make sense because here, what numbers are bigger than or equal to 3? 4, 5, 6, 7, their absolute values. Still 4, 5, 6, 7, still bigger than 3. Over here, if I think of numbers smaller than negative 3, that's negative 4, negative 5, negative 6, negative 7. And their absolute values are 4, 5, 6, 7. When we go back to the original, that makes sense. Their absolute values are still bigger than or equal to 3. But what do we do if it's more than just x? We still want that positive case when we drop the absolute value bars where everything stays the same. But if it's negative, we want the opposite of x minus 3. Again, thinking opposites count too. So solving the left-hand side, we'll get x is less than or equal to 8. Or now we've got to start with distributing. Now remember, this is only on one side, so we don't have to worry about flipping the sign quite yet. Then we'll subtract our 3 from both sides. Then dividing by negative 1, we will get x is less than or equal to, oh wait, looks like I didn't switch the sign. That's a common pitfall, make sure you do. So our answer is x is greater than or equal to negative 2. That's not very clear. I'm going to rewrite it. X is greater than or equal to negative 2 is our answer. So if we were to pick numbers like this, let's see, what numbers are smaller than or equal to 8? We'll pick 7. 7 minus 3, 4. 4's absolute value is 4, which is less than 5. Works. How about over here? X is greater than or equal to negative 2. So numbers greater than or equal to negative 2, let's say 0. 0 minus 3, negative 3. Negative 3's absolute value, 3. 3 is less than or equal to 5. So we see that this works as well. Let me know if you got questions on this, because the absolute value solving can be tricky and that's pretty new to you. But here is your homework for the night, 5 through 53 odd, but you do get to skip number 29. Let me know if you got questions on that at all.